Now we are going to discuss about potentiometer. Potentiometer is used to measure unknown EMF or potential difference accurately. We know there is another device to measure potential difference across 2 points, that is called voltmeter. But this potentiometer gives more accurate reading than voltmeter because voltmeter draws some amount of current from the circuit, but here in a potentiometer it does not draw any current from the circuit, and hence it measures potential difference more accurately, and hence it is also considered as an ideal voltmeter. Now the potentiometer consists of 4 or 10 meter long wire of uniform area of cross section. Okay, and the material is mainly of high resistivity and low temperature coefficient, that means manganese or constant. Such materials are mainly used for making potentiometer wire, and usually 1 meter long separate pieces of wire are fixed on a wooden board parallel to each other like this. These are 1 meter wire. They are placed parallel to each other. Here this represents 4 meter potentiometer because 4 wires are connected. If you are considering a 10 meter potentiometer, means 10 wires will be connected parallel. Now 2 wires are connected. This is 1 meter wire and here another 1 meter wire. They are connected parallel and they are connected by a metal strip, a copper metal strip. Here also thick copper metal strip is used. Why? Because as thickness increases, we know area increases and resistance can be decreased. So in order to decrease the resistance or increase the conductance, what is used? Thick copper strips are used. And the whole wires are arranged on a wooden board, that is a potentiometer. So potentiometer consists of 4 meter or 10 meter wires having high resistivity and low temperature, and each wires are 1 meter and they are fixed parallel to each other, and the wires are connected by thick copper strips, and the whole arrangement is placed on a wooden board. Now working principle of potentiometer. When constant current flows through a wire, the potential drop across any length of the wire is directly proportional to that length. So potential difference is directly proportional to length of the wire. Potential difference across any length of the wire is directly proportional to that length, keeping current constant if current is kept constant. So we can write from Ohm's law, V is equal to I into R, or equals I into resistance R is rho L divided by A, or V is equal to I rho by A is a constant. So K into L. What is the constant K? I rho by A, because here in a potentiometer current is kept constant. Or we can write potential drop is directly proportional to length, keeping which one constant? Current is constant. And here the constant K is called potential gradient. K is called potential gradient, that is potential difference per unit length. K is V by L, potential difference per unit length, and hence it is called potential gradient, and its unit is volt per meter. Okay. Now we can discuss what are the applications of potentiometer. We know the principle behind the working of potentiometer is if current is kept constant, potential difference is directly proportional to length. Now first application of potentiometer is it is used to compare EMFs of 2 primary cells. Now consider this potentiometer. The parallel wires are connected by thick copper strips. Okay. So this is one end A and other end B. So this represents a potentiometer. From the end A battery is connected, positive is connected, negative is connected to key, and from the key it is connected to ammeter, and it is connected to the rheostat, and the top end is connected to, varying end is connected to the B end. Again from the point A, one cell, one primary cell. Usually this cell is Leclanche cell, a cell called a Leclanche. Leclanche cell is connected, and this is Daniell cell is connected. 2 cells, primary cells are Leclanche cell and Daniell cell. So from the point A, first cell is connected, and from the point A, second cell is connected. And negatives are connected. This arrangement is called two-way key. two-way key, and it is connected to the galvanometer and it is connected to the jockey. Jockey is used for sliding contact as seen in potentiometer. So this is the arrangement connection behind the comparison of EMF of the two cells. So once more, potentiometer, here it is connected to battery, key, ammeter and rheostat, and same from the point A it is connected to the two cells positive, two primary cells which are Leclanche and Daniel, and the negatives are connected to the two-way key, and it is connected to the galvanometer which is connected to the jockey which can slide over the potentiometer wire. You will do this experiment in the lab during your physics practical period. Okay. Now, if key is pressed, so that current flows through the potentiometer. Current is kept to constant. So that current can be measured by the ammeter, and if you want to vary the current, that current can be varied by using this rheostat. So keeping rheostat constant, current is kept to constant. Okay. So constant current flows through the potentiometer wire. Now, this key is pressed, that means the key between the cell of the negative cell, the negative of the cell E1 and galvanometer, this key is pressed. So that which cell is in the circuit? Leclanche cell having EMF E1 is in the circuit. Right. Now, jockey is moved from one end to another so that the galvanometer shows zero deflection or null deflection. That is the first step. So, keeping this key K closed, constant current is allowed to flow through the potentiometer wire. Then this key, that means the key which is connected to the cell and the galvanometer, cell E1 and galvanometer, that key is closed. So that E1 is in the circuit. Now jockey is moved from one end to another so that the galvanometer shows null deflection or zero deflection. Let that balancing length be L1. So let L1 represent the balancing length. L1 represent the balancing length corresponding to the cell E1, cell of EMF E1. Okay. Now, we know according to the principle behind the potentiometer, we know potential difference is directly proportional to length, or EMF is directly proportional to length. Here we can write E1 is directly proportional to its balancing length L1. Or we can write E1 equal to a constant. What is that constant called? Potential gradient, which is given by K into L1. That is the first equation. Now, this key is closed. That means this key which is connected to the E2 and the galvanometer, this key is closed. So that the cell of EMF E2, that is Daniel cell, is in the circuit. Okay. As before, again jockey is moved from one end to another, from A to B, so that at a point galvanometer shows null deflection. Measure that length. So let L2 be the balancing length. L2 be the balancing length corresponding to cell of EMF E2. Again, according to the principle, we know E2 is proportional to L2, or we can write E2 is equal to potential gradient K into L2. Like that is the second equation. If you take the ratio, first equation divided by second equation implies E1 by E2 is equal to K into L1 divided by K into L2. K get cancelled and we can write E1 by E2 equals L1 divided by L2. So we know if you want to find the EMF, ratio of the EMF of the two cells, just take the ratio of the balancing length. L1 is the balancing length corresponding to the first cell and L2 is the balancing length corresponding to the second cell. L1 and L2 we can easily measure by using the potentiometer. So if you know the ratio of the balancing length, we can directly find out the ratio of EMF. So that is the first application of potentiometer, comparison of EMF of the two primary cells. Now we can discuss the second application of potentiometer, that is the determination of internal resistance of a primary cell. Now this is a potentiometer, terminals A and B. A is connected to the battery. Here this represents the battery and the negative of the battery is connected to the key, which is connected to ammeter negative, which is connected to the rheostat, and the varying in is connected to B. And this connection is called primaries connection or primary circuit. This is primary connection. And A again is connected to another cell, which can be a Leclanche cell or Daniell cell, and whose internal resistance we have to calculate. And the positive is again connected to R. R is the resistance box, which is connected to another key, which is K2, and which is connected to galvanometer, and it can slide over the potentiometer wire, and hence the jockey is connected. And this arrangement is called a secondary connection. This is called a secondary connection. The primary cell, resistance box, a key and a galvanometer represents secondary connection. Okay. Now, K1 is closed so that a constant current flows through the potentiometer wire. Now, key K2 is kept open. This key is kept open and move the jockey along the wire so that it balances the EMF E of the cell. Okay, K2 is open so that this resistance box is not included in the circuit, and the jockey is moved along the potentiometer wire so that it gets a balancing length. It gets, this galvanometer shows zero deflection at the balancing length L1. Okay, so we can write, if K2 is kept open, let L1 represents the balancing length. L1 is the balancing length. Balancing length. Therefore, we can write E is directly proportional to L1. Okay, resistance is not included, resistance box is not included, K2 is open. We can measure the balancing length as L1. So, E is directly proportional to L1. That is the first equation. Now, K2 is closed. K2 is closed, that means resistance is also included in the circuit. Now, take one resistance from the resistance box, a constant resistance from the resistance box. Now, again jockey is moved from A to B so that at a point galvanometer shows zero deflection. Let that balancing length be L2. So, K2 is closed, L2 is the balancing length. Find out the balancing length, and that balancing length be L2. Now, current is drawn from the cell, isn't it? When key is closed means current is drawn from the cell. Now, the difference in potential is called potential difference, that you know. So, if no current is drawn from the cell, that is EMF. If current is drawn from the cell, the difference in potential is called potential difference. So, now we can write potential difference is directly proportional to L2. So, once more, if K2 is open means only cell is included in the circuit, resistance box is not included, and hence no current is drawn from the cell. Therefore, the balance length, let it be L1, so E is directly proportional to L1. If key K2 is closed means current is drawn from the cell which flows through the resistance box. So, since current is drawn from the cell, the difference in potential is potential difference, which is represented by V. So, V is directly proportional to the corresponding balance length, which is L2. So, V proportional to L2. Okay. Let that is the second equation. Then we can take 1 by 2. The first equation divided by second equation implies E by V. Okay. 1 by 2 implies E by V equals L1 divided by L2. Here the proportionality constant is potential gradient, which is constant, and hence it can be neglected. Right. So, E proportional to L1 or E equal to K into L1. V proportional to L2, which is given by V equal to K into L2. Okay. So, E by V can be written as L1 divided by L2. And we know the relation between EMF and potential difference as V is equal to E minus I into R, that you know. V represents the potential difference, E represents the EMF, I is the current, and R is called internal resistance, that you know. So, V equal to E minus IR, and hence E can be written as V plus IR. So, this E can be written as V plus IR divided by V is equal to L1 divided by L2. But what is this V? Potential difference is given by I into the resistance R. V equal to IR, no? So here V can be written as I into R plus R, because V is equal to IR. So I can be taken common. I into R plus R divided by V. Again V is equal to IR. So IR is equal to L1 divided by L2, since V is equal to IR. Okay, so I get cancelled and we can write R plus R divided by R equals L1 divided by L2. Our aim is to find out this internal resistance. So 1 plus R by R equal to L1 by L2. So R by R equals L1 by L2. This 1 come to the right side, minus 1. So R can be written as capital R into L1 by L2 minus 1. This is the formula for internal resistance of the cell, which can be determined using potentiometer. Small r equals internal resistance R equal to capital R. Capital R is the resistance included in the external cell. Secondary connection. L1, that is a balancing link with key open. L2 is the balancing link with key K2 closed, minus 1. And it can also be written as R equal to R into L1 minus L2 divided by L2. Okay, so this is the formula for internal resistance of the cell, and which can be determined using potentiometer.